negative integer? Anyone can tell me what's a non-negative integer?
Any number that's not negative.
That's not negative. Can it be like 1.2?
Oh, whole number.
Whole numbers. So basically I'm talking about n can be anything. 1, 2, 3, 4, so on. It cannot be negative numbers, but it can be 1, 2, 3 for anything. So my let n be a non-negative integer. Okay. And let a0, a1, a2, so on up to an be real numbers. These a0, a1, a2 up to so on up to an, they can be anything. They can be anything. Except imaginary, they can be anything. So they can be negative 2, they can be 1.5, they can be square root of 2, they can be anything. But they cannot be imaginary, they cannot have iota in it. Okay. And also my an should not be equal to 0. It can be anything but not 0. Then function is defined as, how is your function defined as? An x to the power of n plus an minus 1 x to the power of n minus 1, so on up to a1 x1 plus a0 is equal to fx, you can say, is equal to fx. Don't get confused with why this big term. You're like, oh, this is such a big thing. Polynomials are too complicated. No, they're not complicated. It's just the way they have written it. It looks like that, but it's not that complicated. You'll see when we'll do examples. Okay. Here the highest power of n. So whatever n here, see, n x is raised to power n also, x is raised to power n minus 1 also, 1 also. The highest of them here in this case is n, is of the highest power of x, you can say, is called degree, is called degree. Highest power of x is called degree, and the coefficient of highest power is called leading coefficient. You're like, what does that mean? So you should know what is leading coefficient. Leading coefficient is basically the coefficient, the number next to the highest power. If n is the highest power, an will be my leading coefficient. If n minus 1 is the highest power, an minus 1 will be my leading coefficient. Examples. Let's take examples first of all and see whether these are polynomials or not. I have fx is equal to negative 3 x to the power of 5 plus square root of 2 x to the power of 2 plus 5. You're given this thing. So basically in a polynomial, the power of x should always be integers, positive integers. These coefficients next to x, they can be anything. They can be anything except imaginary. They can be any real numbers. If that's true, this is a polynomial. Let's check. What are the different powers of x? You don't have to write in general, but this is an example, so I'm going to write it. Different powers of x. Okay, let's see. Can I have Alexander? Is Alexander here? No. Jamie?
Yeah.
Okay, what are the different powers of x you see in this question here?
5 and 2.
5 and 2. Correct. See, x is raised to power 5 and x is raised to power 2. So these are the powers of 2. If I say what's my an minus 1 and so on, what is it? That's the coefficient of the, what's the coefficients here? Negative 3. These are my, so negative 3, square root of 2 and 5. Note, are these 5 and 2 my non-negative integers? Yes, they are positive and they are integers. Correct. So that means this condition is satisfied. Are these my real numbers? Yes. So that means this is a polynomial. What's the degree? Highest power is 5. So degree will be 5. What's the leading coefficient? Since degree is 5, I'm going to just look at this term here. I'm just going to look at this term here. What's the number next to x to the power of 5? Since degree is 5, I'm going to just look at this term. That will be my leading coefficient because that term has the highest degree. So the coefficient of that term will be the leading coefficient. Anyone who did not understand this part, how to figure out whether it's a polynomial or not, and then how to figure out if it has a degree or leading coefficient?
Yeah, Miss K, I just want to clarify, how do we determine that the degree is 5? How did we get the degree being 5?
So, degree, what you're going to see? You're going to see the powers of x. The power of x is 5 and 2, right? You're going to take the highest one, the highest value. In this case, it's 5.
Okay, thank you.
Yeah, perfect. Anyone has any other questions?
I have a question.
Yes.
So where it says, where you're writing, it says highest power of, what does that say exactly, where it's kind of
X.
scribbled?
Highest power of x.
Okay.
Yeah. Any other question, anyone?
Could you re-explain that where you wrote an, comma, an plus dot dot dot, and then you wrote the coefficients?
Okay. So basically, I'm trying to figure out my coefficients here. Rather than writing here, you can write coefficients. What are my various coefficients here? Okay, from this term, my coefficient is negative 3. From this term, my coefficient is square root of 2. And from here, you have 5. That's what I'm trying to say. And these should be real numbers. Okay?
Thank you.
Yeah. Okay, let's take one more example. I'm going to take one more example. So you have negative 3 square root of x plus square root of 2 x square plus 5. Power of x. Let's see power of x. Tracy? Is Tracy here?
Yeah.
Yeah. So what are the different powers of x I have here?
2.
2. What about this? Square root.
1.
How do you write the square root as? Is there any other way you can write square root as x to the power of? It's a square root, right? You can write as 1/2.
X to the
If it's cube root, it becomes, if it's cube root, it will become 1 to the power of 3. Okay? So that's
Why didn't you do that in the first example for like your powers of x?
So in there it was whole numbers. I didn't know how to do it. 5, 2. I didn't know how to do it that place. But in this case, I need to find the power of x, right? So here I have a square root sign. So I need to write it in this form to know what's the power of my x. So in this case, I have two powers, 2 and 1/2. Note my powers are supposed to be non-negative integers. They are supposed to be non-negative integers. 1/2 is not integer. 1/2 is not an integer. So this is not a polynomial. Since 1/2 is not an integer, or you can say positive integer, therefore it is not a polynomial. Not a polynomial. Anyone who did not understand why is it not a polynomial?
If it's -3 and then square rooted x, wouldn't it be 1/3? Or is
No.
that not in the
No,
square root?
it's not in the square root. It's a different number.
Okay.
Yeah, yeah. Any other question, anyone?
Can you repeat where it says since 1/2 is not what?
Oh, I cannot hear you. Your voice was breaking.
She said, can you repeat where 1/2 is not, like the very bottom, since 1/2 is not an integer? She wants you to explain that again.
Okay, she wants me to explain that again. Okay, so what happened is here, what I'm trying to do here, Leah, is I'm trying to figure out the powers of x. So what are my different power of, from here I know my power of x is 2. But what about this thing, square root of x? Square root of x, square root, basically you can write it in this form, 1 over 2. That's how you write square root. If it's cube root, you write as 1 over 3. Okay, but here I have square root, so I'm going to write as 1 over 2. Note in the definition, if you see in the definition, they say n be a non-negative integer. So that means n is a powers. Power should be non-negative integer. They can only be 1, 2, 3, 4, 5, 6. Like these numbers, they cannot be 1/2, 2/2, 3/2 or negative numbers. Are you getting my point, Leah? But in this case, I'm getting this 1/2. So that means this is not a polynomial. What is given here is not a polynomial. Okay.
But if for the coefficients, let's say that the powers of x were good, they were positive integers. What if the coefficients weren't?
Coefficients can be anything.
Never mind.
Coefficients can be anything. I don't care about my coefficients
Yeah.
other than, yeah. They cannot be imaginary, but they can be anything.
Okay.
Yeah. Any other questions, anyone? Okay. So let's do one more example. I'm going to do here is, so you're given here example. You're given gx is equal to negative 3x to the power of 4, x minus 2, x plus 3. You're given this thing. You're like, oh, this is not in standard form. If it's not in standard form, make in standard form. Let's open the bracket first. I'm going to multiply these two first using the FOIL method. FOIL. First, you multiply the first terms. X times x. So minus 3x to the power of 4 remains as it is. I'm first multiplying x times x, which gives me x squared. O, outers, x times 3, 3x. I, inners, negative 2x. And last ones, you get negative 6. Combine the like terms. You get x squared. 3x minus 2x is just x, and you get this thing. Then let's open it. Multiply this, you get negative 3x to the power of 4 times x squared. Negative 3x to the power of 6. Then you have negative 3x to the power of 4 times x. You get negative 3x to the power of 5. Then you multiply, you get 18x to the power of 4. This is the polynomial that you get. Let's see, now I need to check whether this thing is a polynomial or not. Benjamin?
Yeah.
What are my powers of x?
Powers of x are 6, 5, and
I cannot hear you, Benjamin.
4. Powers of x are 6, 5, and 4.
Are they non-negative integers? Okay, so they're good. So power of x is good. So let's go to the coefficients. What are the different coefficients I have here? Coefficients. Okay.
Negative 3 and 18.
Negative 3, and 18, right?
So you have to write both of them?
Yeah, you have to write
Both of the negative 3s. Okay.
Yes. Negative 3, negative 3 and 18. They can be anything except imaginary. So I'm good. This is a polynomial. This is a polynomial. Okay. Since it's a polynomial, let's figure out the degree and leading coefficient. Benjamin, what's my degree?
Degree is 6.
Yeah, the highest power. The highest number in power is 6, so my degree becomes 6. And what's the leading coefficient?
3.
Yeah, negative 3, correct. It's going to be negative 3 because since my degree is 6, I'm just going to look at this term now. I'm just going to look at this term now. And what's the coefficient next to x to the power of 6? Negative 3. So my leading coefficient becomes negative 3. Any questions, anyone?
So it doesn't matter if the coefficients are negative, it'll still be a polynomial.
Yes, coefficients can be any number, any real number. So technically they can be any number. Any number, but these power of x, they should be non-negative integers. Any other question, anyone? Okay, so let's take one more example. The last example I'm gonna do is, so you have given gx is equal to negative 3 over x square plus square root of 2 x to the power of 2 plus 5. You're given like this. And you have to tell whether this thing is a polynomial or not. Jacqueline, she's not here. Melanie?
Yeah. Wait, you asked what? If it's a polynomial?
Yes, you have to check. But let's see one thing. First of all, is it in standard form, Melanie?
Yeah.
Because I don't have denominators here. I don't have x in my denominators. In standard form, my x is always supposed to be on the top.
Oh, I know.
How do I take it on the top? Do you know?
Do you multiply it by x squared?
No. How do you do it is, how do you take it is, since it's x to the power of 2, you can take it on the top. X, you can take it on the top, but you have to change the sign of the power. If it's positive, you have to make it negative. If it's negative, you have to make it positive. So you change the sign, you can interchange the places, but then you have to change the sign of the powers. If it's positive, it will become negative. X will still remain x. Only the sign of the power changes and everything else remains the same. Now it's in standard form. Now let's talk about the powers. Powers of x. What are the different powers of x here, Melanie?
Negative 2 and 2.
Are they non-negative integers?
Sorry, what?
Are they non-negative integers?
The negative 2 is negative.
So it is not a polynomial. Since one of the power of x is equal to negative 2, therefore it is not a polynomial. Any questions, anyone? How to figure out what is a polynomial and what is not a polynomial?
So if there's a negative power of x like anywhere in the problem, then it's not a polynomial automatically.
Yes.
Okay.
And if it's not a polynomial, you cannot find the degree, you cannot find the leading coefficient.
If the coefficient is 1/2, can it still be a polynomial?
Yes.
Yeah.
Yeah. Any other questions, anyone? Okay. So next thing what I'm gonna tell you is about the graph. Something about the graph you should know is, whenever a graph is given to you for a polynomial, how does generally the graph of polynomial looks like is, it's gonna be either like something like this. It goes up and down like this. This is how the graph of a polynomial generally looks like. Okay. Note, it is always smooth. It is always smooth. What does smooth mean is, it's always like this. Curvy. It's curve here. You cannot have like this. Oh. You cannot have like this. Sharp ends. If you have sharp ends, it is not a polynomial. Just one thing for you to note is, my polynomial always have smooth curve. So it has like curve here. Smooth. It's smooth here. It is not sharp. It doesn't have sharp ends. Other thing about polynomial is, it also is continuous. Smooth and continuous. What does continuous mean is, you can draw it in one go. You can draw it in one go without lifting your pen. You can draw it in one go. So if I say I have something like this, I say like this, and then I stop, and then I make like this. This is not a polynomial. This is not a polynomial. Why? I drew this, but then I lifted my pen because I'm not drawing this part, and then I drew again. So this is not a polynomial. It should be smooth. That means it should have curves, and also it's supposed to be continuous. You can draw it in one go. This is one of the properties of polynomials. You should just know it.
So would that make a, what's it called? What is that thing called? The U or the big N one?
Parabola.
Parabola. That's what it was.
Yeah, parabola.
That would be a polynomial, right?
Yeah, no, parabola. No, it's not a parabola. That's actually a quadratic. There are multiple parabolas here. Then, that's what you can say. Yes, but not. Yeah, it's not a parabola. It's just here you just call it curve. It doesn't have any special name for this. Yeah. So now I'm gonna go 2 steps. Now we go to the main part. Now we are gonna go to the main part. So before I give you the steps of how to graph, you would need to understand some few things. First thing is leading coefficient test. Leading coefficient test. So you will be given a polynomial. You will be given a polynomial. You have to figure out your degree. You have to figure out your leading coefficient. Okay, so you'll be, suppose leading coefficient. Okay, first leading coefficient, what you're gonna do is you're gonna figure out your degree and you'll call it as n. I'm calling my degree as n, and then you're gonna figure out your leading coefficient as an. I'm calling it as an. Okay, this is what you're gonna do. What you're gonna do it is you're gonna look at your n. Is n is odd or n is even? Can anyone tell me what is odd and even? What are odd numbers?
1,
3.
3, 5.
Exactly. Odd numbers are 1, 3, 5, 9, so on. Numbers which you cannot divide by 2. And even is opposite. Numbers which you can divide by 2. And so on. So you have to check whether n is even or odd. Your first step is to check your degree. N is basically degree. Note here, I call n as degree. So you have to check whether it's odd or even. Once you check that, what you're going to check is you're going to look at your an. You're going to look at your leading coefficient. Is it positive or is it negative number? Is it positive or is it negative number? Similarly for even also, you have to check whether it's positive or it's negative. What it's going to tell me? If it's positive, you know what does leading coefficient test tell me? It tells me the end behavior of the graph. End behavior of graph. It tells me at the ends of the graph how my graph is gonna look. At the very ends, how my graph is gonna look. So how it's gonna tell me this thing. So if an is greater than 0, your end behavior will be like this. The end of the graph will look like this. This side of the graph will be facing downward and this side will be facing upward. And if it's less than 0, it will be opposite. This side it will be upward, this side it will be downward. So if your n is odd and it is greater than 0, you know this is your end behavior. N is odd, less than 0, you know this is your end behavior. If n is even and greater than 0, both end sides will be upward facing. So you'll put at the end like both arrows which are facing upward. And if it's less than 0, you're gonna put it downward. Both will be facing downward. And we are going to do examples and you'll know how to use this. Let's do an example. So you're given fx is equal to x cube plus 3x square minus x minus 3. They say you have to use a leading coefficient test to figure out the end behavior. Leading coefficient test to figure out the end behavior. Sean?
Yes.
What's my n in this case?
It would be 3.
And what's my an?
Would be 1.
Perfect.
Oh, it would, yeah.
Perfect, yes. So which side I'm looking at? I'm looking this side or this side?
You're looking at the odd.
Odd one, okay. Odd greater than 0 or less than 0?
It is greater than 0.
So this is how it's gonna look like. So if I technically start graphing my graph, I know this side is gonna be downward and this side is gonna be upward. My end of the graphs is gonna look like this. This is the first step.
Sorry, I have a question.
Yeah.
In this case, why do you need to know what the degree is?
Because that's n is the degree, right? N is basically the degree. That will tell you which side to look, whether you're looking at this side or whether you're looking at this side. Yeah. Any other questions, anyone? Okay. Let's do one more example. So you're given fx as x to the power of 4 minus 4x cube. I want everyone to do this. X to the power of 4 minus 4x cube. Figure out your n, figure out your an, and compare which one it is. Cole, Adam?
Yeah.
Okay, what's my n?
Your n is 4.
An?
Uh-huh.
An.
Your an is 1. Wait.
Yes, if it's
No.
nothing, it's 1 there, next to it. How is my graph gonna look at the end, Cole?
Going down. Wait. No, going up.
Going up both sides?
No, starting going down, then ending going up.
Okay, n is even or odd?
It's on odd.
N is 4.
No, n is even.
Even. So I'm
AN
looking
is
at
odd.
this side. I'm looking at this side only
okay.
now.
So it's gonna go up twice.
Yeah, it's gonna be up both sides. Perfect. Any questions, anyone, how to figure out? So this is your first step of graphing. You're gonna do the leading coefficient test and figure out how the ends of my graph is gonna look. Okay. There is one more.
So,
Yeah.
sorry, the arrows, they apply to n and not an for the...
And n tells me which side to look, whether I'm looking at this side of the, or I'm looking this side.
Okay.
Yeah. And an tells me which one. See, if it's odd, it's either up, one side up and one side down. N tells me one side it will be down, one side it will be up. I mean, don't get confused by this. Just remember, n tells me which side I'm looking at, this side or this side. First you look at your n, then you look at your an.
Is your an odd? So wouldn't it be?
An we are not looking for odd even. An we are looking whether it's positive or negative number. N we are looking at for even and odd, but for an we are looking at whether it's a positive number or a negative number. In this case, note, we got 1 which is greater than 0, right? 1 is greater than 0.
Yes.
So odd greater than 0 was this thing. That's why I used this one here.
Okay.
Here I was getting...
just...
Yeah.
Never mind.
Yeah, say Cole. It's okay. You got it? Okay, you had your question. Say.
It just, to me, it seems like because your an is 1, so wouldn't it be like 1 is greater than 0, so wouldn't it be the very first one down then up?
But then n is, what is your n?
Your n is 4.
Which is even or
So
odd?
is it like your n is even?
So you have to look at the even side of the box. So you will look at the even. First you look at the n, which is it even or odd? Then it will tell you whether I'm looking at this side or this side. And then you look at your an. If an is positive, since it was even, I'm just going to look at this side now. If it's positive, it's going to be both upward facing.
Oh, is n more important than an?
Yes, exactly. N is more important than an. Yes. Okay. Let's do one more example here. This was in standard form here. And you figured out your an, which was pretty easy. You figured out your n, you figured out your an. You did the leading coefficient test, which was very easy. But suppose you are given something like this. Fx is equal to negative 4x cube x minus 1 whole square and x plus 5. You get something like this. And they say you have to figure out the n and an for this one and do the leading coefficient test and find your, how the n behavior will be of the graph. Note in this case, one thing you can do is open the bracket and start, multiplying, opening the bracket, and then you can figure out your n and en. Easy way of doing it is, so what you can do is, this is easier way. Figure out the degree. So there are 3 terms here, right? 3 terms here. Okay. This multiplied by this, multiplied by this. What's the highest power of x here? 3. Okay. From this term, x minus 1 square, anyone who can tell me what's the highest power of x here?
It would be 4.
It will be 4, x minus 1 whole square. Just x minus 1 whole square. What will be the highest power?
Wouldn't it be 2?
It will be 2. Since it's square, it will be 2. What about here? What is the highest power here? What's the highest power of here? X here?
1.
1. So when I'm talking about power, what will be my degree? You add all of them and that will be your degree. So in this case, the degree of this polynomial is 6. This is an easier way of finding the degree. Rather than multiplying everything, opening, and then figuring out your degree, this is easier way of finding degree. If a problem is given like this, figure out the degree from each term. Here, power is x. From this term, it is 2. From here, it is 1. And add all of them. That will give you the n. So I know my n is 6.
Okay, so how would you find the leading coefficient though if there was another number attached to the x?
So let's see. Let's do the leading coefficients. For degree, you add. For leading coefficients, what you're gonna do is, let's see here. Let's talk about leading coefficients here. Now I'm gonna talk about an. So what's the coefficient of here x? -4. Here you said it would be x square, right? The highest degree in this term would be x square. What do you think would be the coefficient of x square in this case? If you try to open it, it would be 1. So here it would be 1. What about here? What's the coefficient of x here? 1. So it will be 1. And you multiply. In case of an, you multiply. So in case of leading coefficients, you multiply. In case of degree, you add. When you multiply, you get -4. So I know my an is -4. That's how you figure it out.
A question. So how do you know when to use this? Like when to do the adding all the...
When it is not in standard form. Whether it's not in standard form, right? My standard form is something like this, like a x to the power of n plus b x to the power of n minus 1 plus c, so on, x to the power of n minus 2, so on, up to you can see like d, something like this. You have standard form like this, but it is not like that. Here it's not like this. It is something multiplied by something multiplied by something. That way you can use this thing. If it's directly given in standard form, then you know directly what's your n and an.
So the third example we did wasn't in standard form, but we didn't use this method.
Yeah, we did not use it. Yeah, we can use that method also. So if I go back to that thing, let's see. Let me take out the third example here. Here, let's see the third example. If I say I need to find the degree of this one, so I have this one. From the first one, the highest power is 4, so I'm going to write 4. From the second one, the highest power is 1, so I'm going to write 1. And then again, it would be 1. And then you add all of them. So you get 4, 5, 6. Note my degree was 6. You told me n degree was 6 yourself. Now let's figure out the leading coefficient. From here, what's the coefficient of x to the power of 4? -3. Coefficient of highest power here, it was x, right? So here it's 1. So I'm going to multiply. In case of coefficients, you multiply. And then from here also you have 1. You got -3. See, it's the same answer.
So you can use, there's 2 different methods to use every time it's not in standard form?
Yes. It's just that I taught you, you can do it that way also, that's also correct, but this is just an easier way and faster way to figuring out how you know your n and an. Now you know your n and an. Cole Raymond.
Yes.
Okay. Can you tell me how my graph is gonna look at the ends?
Is it gonna be Is it gonna be the 2 upward arrows?
2 upward?
Is it? I think so. That's what I think it is.
Okay,
I don't know.
what is n? N is even or odd?
N is even.
So I'm just gonna look at my even side now. I'm just gonna look at my even side. Okay. So basically I'm looking at just this side here now. I'm just looking at this side. What about your an? An is positive or negative?
Your an is negative.
So n even and negative. It's this thing. So both will be downward.
Okay.
Yeah. So both sides is gonna be downward.
Oh. Wait, so I think I get it. So your n, like whether it's even or odd, that chooses which side it's on, the left or the right, and then
Exactly.
the an is okay. I get it.
Exactly. You got it. So first you always n, then an. Exactly. Any questions, anyone? Okay. If you got this, I want everyone to find n and an themselves for this one. You have fx is equal to negative 2x cube x minus 1 x plus 5. Find the degree and an n. So you need to tell me what's my n and what's my an from this thing, and you need to tell me what's the n behavior. Do it yourself right now. Gianni,
Yes.
can you tell me what's my n?
Your n is going to be 5 because you take 3 from negative 2x cubed, and then you take 1 from x minus 1, and then you take 1 from x plus 5. So your answer is 5 for your n.
Perfect. What about
And then
an?
for your an, it's going to be negative 2 because you take negative 2 as the first number, and then 1 from x minus 1, and then 1 from x plus 5.
And then you multiply, right?
Yes.
And how is my n behavior, Gianni?
Sorry, well, I couldn't hear what you said.
End behavior. My graph. How is my graph gonna look?
It's going to be an 1 up arrow and 1 down arrow.
Which side is up and which side is down?
The left side is up and the right side is down.
Yes, perfect. So you have to be very particular. Which side is up, which side is down. Any question, anyone, with this thing? Let's do one more example here. I'm going to do one more example and you're going to tell me what's my n and an. So you have minus 49x cubed plus 806x squared plus 377 6x plus 2503. You need to tell me the n behavior. Evander is not here. Aiden?
Yes.
Okay. Can you tell me what's my n and an?
Okay. Give me a second.
Mm-hmm.
3, 2, 1. So n would be 6.
Why 6?
What?
Why 6?
Because oh wait, it would be 0, right?
N is 0?
No.
Is this in standard form, Aiden? Is it in standard form?
I think so.
Yes. When it's standard form, you don't have to use this method here. This method you use when it's not in standard form.
Yeah.
Here you can directly tell me what's my n and an.
3 and negative 49.
Perfect, yes. So what's my graph? How is my graph gonna look?
And then, okay, down on the left and up on the right.
Down on the left and up on the right. Are you sure? Check again. Odd.
Yeah, up on the right, down on the left.
It's up on the left and down on the right.
Yeah.
See here. Odd and negative. Odd and negative. It's up on the left, down on the right. Any questions, anyone? How to do the leading coefficient test? No? Okay. So I'm gonna move forward from leading coefficient test to something else now. Is next step is so to find your x-intercept. To find your x-intercept. So first step was to find the leading coefficient and figure out your this thing. Step 2 is to find step 2. Step 2 is to find x-intercept and their multiplicity. I'm gonna tell you what's your x-intercept and their multiplicity. Anyone who knows, we've been doing this, we've done this before, a property about x-intercept. Anyone which we use?
0.
Y is 0. The opposite. For x-intercept, your y is 0. So suppose if I, suppose I say you're given something as, let me see if I have here some problem here. Okay, if I say fx is equal to, x square minus 4x plus 4, I am given this thing. This is my polynomial function which is given to you. I say find the x-intercept and their multiplicity. What you're gonna do, you put your fx is equal to 0, you get this thing, and you know how to find your x-intercepts in this case. Use the quadratic formula. Minus b plus minus square root of b square minus 4ac over 2a. You put in this formula, find the value of x. When you will do it, you will get x is equal to 2 and x is equal to 2. That's what you're gonna get your answer as. Solve and check. Are you getting the same answer? Put in this formula the value of a, b and c and see if you're getting x is equal to 2, x is equal to 2. Usually this formula gives you two answers. This formula gives you two answers. Either it will give you two answers or no answer. This formula either gives you two answer or no answer. If you're getting one answer, that means that is coming twice. So you get this thing. So in this case, your x-intercept will be 2, 0. And you know what does multiplicity tell? Multiplicity is usually denoted by k. Multiplicity is usually denoted by k. K tells me how many times is my 0 coming. How many times is that 0 coming? How many times here it's coming? 2. So in this case, my multiplicity will be 2. For 2, 0, my multiplicity will be 2. K multiplicity tells me how many times is my 0 coming. Since here it's coming twice, so 2, 0, this 2, 0 will have multiplicity 2 because it's coming twice. Any doubts with this one? With multiplicity and how to find the zeros. Let's do more examples on this. What if it is not a quadratic? When it's quadratic, ax square plus bx plus c, you choose quadratic formula. But what if I say you have something like this? You have, suppose fx is equal to x cube plus 3x square minus x minus 3. You have this thing. Okay. You have this thing and I want you to find the value of x for x-intercept. For x-intercept, first step is to put y as 0. You got this thing. Now you need to find value of x. You cannot use quadratic formula. You cannot use quadratic formula because you have x to the power of 3 here. If it was just this much, then you can use quadratic formula and find it. But in this case, you don't have you have an extra term, x to the power of 3. How do you solve problems like this is, you will first one, step 1, try to take out common from all terms. Try to take out common from all terms. That will be my first step. I want to take out common. Okay, this term has 3x, x times x times x. This has a number 3 and 2x. This has 1x and this has 3. Is there anything common between them? Jasmine?
Yes.
Okay, so Jasmine, here I have x cube here. Okay, here I have 3 and x square. Here I have x and here I have 3. Okay, is there anything common between all of them?
No, I don't see anything.
I cannot hear you, Jasmine.
No.
Yeah, I can. I mean, it's very low. It's okay. But yeah, is there anything common between them?
I don't see anything.
Yeah, there isn't anything. These 3 have x. This does not have x. So I cannot take out common. So if there is nothing common, you go to step 2. Okay, step 2 is try to make, you can say, try to use quadratic formula if it is in ax square plus bx plus c form, or make pairs you can say, rather than writing, make pairs. So in this case, I cannot use quadratic formula. First of all, there was nothing common. I cannot use quadratic formula. So what I'm gonna do is, I'm gonna make pair. I'm gonna make pair of first 2 and last 2. Since there were 4 terms, I'm dividing into halves. I divide the first 2 into 1 half and the second 2 into 1 half. So these 2 I'm considering, and then I'm gonna consider these 2. Now let's see. Jasmine, is there anything common between x cube plus 3x square? Just these 2.
You can take out 2 x's.
I can take out 2 x's. When I take out 2 x's, what I'm left with inside?
X plus 3.
Perfect, perfect. Next thing what I'm going to try to do is, I'm going to take out common from this thing. But I want to take out common in such a way, whatever I have inside the bracket here, I want the same thing inside here too. So Jasmine, what can I take out common?
What?
Now I have to take out common from these 2. Okay? I want to take out common such a way that I want to make it as x plus 3.
Multiply the negative over.
So we take out the negative 1 outside. Okay? We take out the negative sign outside. If we take out the negative sign, we are left with the same thing, x plus 3. That's what we needed. That's what we needed. We needed to make the same thing here. Whatever was here, we were trying to make the same thing in the other bracket also. Now I have this term minus this term. Now, is there anything common between both of them? Jasmine?
The x plus 3.
Okay, now you are saying there is x plus 3 common between them. Perfect. Okay, what are you left with in the other bracket?
X squared minus 1.
Perfect, perfect. So you try to make factors. See, you made factors here. You made this factor and this factor. Once you got something multiplied by something, what you're going to do is, you're going to put each of them equal to 0 and solve. You'll put each of them equal to 0 and solve. From here, you subtract 3, you get x is equal to 3. That's one of your zeros you got. Here, you add, you get x squared as 1. How do I solve this? Since it's x squared, I'm going to take square root myself. And when I take myself, I need to put a plus minus sign. I get x is equal to plus minus 1. So note, what are the zeros I got? I got 0, I got 3, 1 and negative 1. Okay.
Isn't it -3 because you put -3 on the other side?
Exactly, it's -3. Thanks for correcting that. Yes. So you got -3, 1 and -1. Now I need to figure out the multiplicity of these things. How many times is -3 coming here? Only 1. So my multiplicity of -3, 0 is 1. How many times is 1 coming? Only 1. So multiplicity is 1. What about -1 is also coming 1. So my multiplicity is 1. So first you figure out the zeros. Once you figure out the zeros, you have to figure out their multiplicity. How many times are they coming in the question? If you're done, I want everyone to try this problem is, so you're gonna do fx is equal to x cube plus 2x square minus 4x minus 8. If you're done, I want you to do this right now and figure out the multiplicity of this thing and find the zeros and multiplicity. Kylie?
Kylie?
Yeah.
Okay.
So how do I do? What's my first step? I need to find the x-intercepts.
Hold on, I haven't finished writing this.
Okay, yeah, sure.
So first you, because you can't do quadratic formula,
first I put 0, fx as 0 because I'm finding x-intercept. I put my y as 0. Okay?
Okay.
Okay, now you said you cannot use quadratic because there is x cube, right?
Yes.
Okay, so what I'm gonna do?
Now you go to try and find the greatest common factor of the entire thing, which you can't do.
Yes.
And then after that, you have to make pairs.
Okay, I make pair here. Okay.
So the first pair would be...
What's common between these two?
What's common about the first two is x squared.
Okay, I took out x squared. What I'm left with inside?
You're left with x plus 2.
Perfect. What about the next two? What's common?
4?
You're saying positive 4, right?
Yeah.
Then what are you left with?
And you're left with x plus 2.
No, negative x, negative 2, right? There is negative.
Oh, yeah.
So that's why I'm going to take out negative 4 because I want to write x plus 2, right?
Okay, I see.
So I will get x plus 2. I want the same thing as the first bracket. Did you get it?
Yeah.
Okay, then what can I take out common now?
Now you can take out common the x plus 2.
Okay, what I'm left
which
with
would leave the first bracket x plus 2 and the second brackets would be x squared minus 4.
Okay, perfect. What's the next step?
The next step is to set both of the brackets to 0 and then solve.
Okay, and can you tell me what you get?
So for x plus 2, x would equal to negative 2.
Okay, what about here?
And then for the next one, x would equal to plus or minus 4.
Plus minus 2 because you're going to take square root of 4.
Oh yeah, I forgot about the square root.
Yeah. So what you're getting points as negative 2, 0, you're getting 2, 0. These are the two different points you're getting, negative 2 and 2. How many times is negative 2 coming, Kylie?
1.
Negative 2 you're getting here also. Then you had negative 2 here also, right?
Oh, so you get it twice.
So my multiplicity for negative 2 is 2.
2.
What about 2? How many times is 2 coming?
2 is coming once.
So multiplicity here becomes 1. Perfect. Any questions, anyone?
Yes. So would you leave your multiplicity as 2 and 1, or is it just 2, or is it just 1?
Okay,
Or is it both two, three, and one?
for this point, the multiplicity is 2. For this point, it is 1.
Okay, thank you.
You will see why I'm doing the multiplicity thing. I'm going to explain you. I'm going to explain this part too. Right now, I'm just going to explain how to find multiplicity, but you will need this. Okay. One more example I'm going to do is finding the zeros is, so you're given fx as negative x to the power of 4 plus 4x cube, okay, minus 4x square. You're given this thing. Oh, sorry, you cannot see. You're given this thing. They want you to find the zero of this thing. Jade.
Yes.
How do you do this? Can you explain the steps? I cannot hear you. You're mute. You're mute.
You're so right. My bad. So, it may look like it's a standard, but it's not. But I don't know how to necessarily.
So
actually, hold on. Let me look at my notes.
Do the same as the one we were doing before. X into Z. It's the same method. It's exactly the same method. Let's do it.
I don't know how to like pair them because there's 3.
Okay, let's see.
If I were to like guess,
see, first is you put 0, right?
Yeah.
Okay, you got this thing. Next method, what was the step 1? Can you read the step 1, Jade?
Is try to make common terms, but there's not necessarily
First was try to make out common. Try to take out common from all terms.
Yeah.
Is there anything common between x to the power of 4, 4x cube and minus 4x square?
Yeah, it's the x squared.
Okay, I took out x squared. What I'm left with inside?
Let me actually write this down. Sorry.
Yeah.
So inside would be negative x squared plus 4x minus 4.
Minus 4. Perfect.
And then
since you made factors now in this thing, what you're gonna do is you're gonna put each and every term equal to 0. You cannot do further inside, right? Put each of them equal to 0. I put x square also equal to 0. Whatever I have inside also equal to 0. From here, what do I get, Jade?
So for the x squared equals 0, you would do the quadratic thing, and it would just be plus or minus 0. And then you'd have to do the quadratic
in this quadratic form
for the other one.
Yes, exactly. So you have a as negative 1, b as 4, and c as negative 4. Solve and tell me what you get your a, b, and c.
All right, I'll be quick.
Yeah.
Wouldn't it just be x2 for both?
Yeah, so if you're getting one answer, that means the same answer is coming twice.
Yeah.
Yeah. If you're getting
for
one
both
answer, yeah. Because usually quadratic formula will give you 2 answers. But if it's not giving you 2 answers, that means if it's giving you 1 answer, that means it is coming out twice. So now that my zeros are, the different zeros I got is, so plus minus 0, there is nothing known as plus minus 0. It is 0 only, but it means I have zeros is coming twice. So I have 0, 0. So its multiplicity is 2 because 0 is coming twice. Then I have 2, 0. Since 2 is also coming twice, its multiplicity is also 2.
Weird.
Yeah, good. Any doubts with this here? Anyone?
I have a question.
Yeah.
Because I didn't get x equals 2, so I obviously did something wrong.
Okay, so let's see.
So like,
did you get negative 4 plus minus square root of 4 square minus 4 negative 1 negative 4 over 2 times negative 1? Correct?
Oh, never mind. I was doing the other side. Never mind. I did.
Okay.
I didn't even do that side.
Okay.
I was trying to do quadratic. Yeah, I did it wrong, but I understand what I did wrong now.
Okay,
So
perfect. If you got this,
I'm
that's
fine.
perfect. Yes. Okay, so this is another way of doing. Okay, so this is one way. So zeros, you know how to find zeros, you know how to find multiplicity. Okay, next thing what you're gonna do is, okay, one more problem I want to do is when it's not in standard form, how do you find the multiplicity?
Wait, Miss K.
Yeah.
Miss K, I have a question.
Yeah.
So for the quadratic formula that you put -4 plus or minus.
Mm-hmm.
Isn't it supposed to be? Oh wait, never mind. I figured it out.
Yeah. So you have fx is equal to half x minus plus 1 whole square, and then you have 2x minus 3 whole square. You have this thing, and they say you have to find the x-intercept for this thing, and you have to find, you know, the multiplicity. What you do is, first step you put fx as 0. Note this thing is not in standard form. You know, not in standard form, that is good. It is already in factor form. You put each and every term equal to 0 directly. I put 1/2 equal to 0, x plus 1 square equal to 0, and then I put 2x minus 3 square equal to 0. I do that. Note my 1/2 cannot be equal to 0, so I'm not getting anything from here. What about here? Let's see here. Gets rid of the square. I take square root on both sides. I get plus minus 0. There is nothing known as plus minus 0. There is only 0. So basically I can write as x plus 1 as 0, x plus 1 as 0. I make it into two parts. And when you subtract 1 both sides, you get x is equal to -1. Subtract 1 both sides, you get x is equal to -1. Let's solve this thing. Let's take square root both sides, put a plus minus sign. You get 2x minus 3 is equal to plus minus 0. There is again nothing known as plus minus 0. I'll just put 0 in place of plus minus 0. But I'm going to put it twice since it was plus minus 0. When you solve, you add 3. You get 2x is equal to 3. Divide by 2. You get x is equal to 3 over 2. For here also you will get x is equal to 3 over 2. So what are the different zeros I got? I got -1 0 and 3 over 2 0. These are the different ones. And how many times is -1 coming? Twice. So multiplicity for this thing is 2. What about this thing? Multiplicity is 2. So if it's not in standard form, that's like the easiest way. Put each and every term equal to 0 and try to solve. So this is one thing we did. Now, since we are done with this thing, now we are going to go to the graphing.
Back to the other notes, I wasn't finished writing them down.
Okay, wait. I'll write it.
Alright, you're good now.
Okay. So now we are going to go to graphing. Okay, steps for graphing. Steps for graphing. What are the steps is, so first you're going to do is use the leading coefficient test. Use the leading coefficient test to determine the end behavior of graph. So you're going to use a leading coefficient test to figure out the end behavior of the graph. Okay. Next thing what you're going to do is, find x-intercepts. You will find x-intercepts and you will put for x-intercept, you will put y is equal to 0 and solve for x. And find the and find its multiplicity. Note, when you find the multiplicity, what you're going to do is you're going to look for k, right? If k is even, what happens is, so x-intercept, what does x-intercept mean is, where does my graph cross the x-axis? At what point my graph crosses the x-axis? If suppose here in this example, I'm going to take this example here. So if I'm trying to graph my point graph here, I have -1 here and 3/2 here. Okay, suppose I have 3/2 here. I say my graph is gonna cross here, but if it has even multiplicity, if it has, since this -1 0 has even multiplicity, even numbers means numbers which are divisible by 2, it is gonna go to that point, but it's gonna turn around. It's gonna turn around at that point. It will touch that point, but it's gonna turn around at that point. If it has odd multiplicity, suppose in this case, let's see, I have to take an example where it had odd multiplicity. If it has odd multiplicity, it crosses. So if it's even multiplicity, it will go to that point and turn around. It can be this way turn around, or it could be downward turn around. It will touch that point, and turn around at that point. If it has odd multiplicity, suppose it's this thing, it's going to touch that point and cross. It's going to touch that point and cross at that point. That's the reason we figure out the multiplicity. If it's even multiplicity, it turns around. If it's odd multiplicity, it touches and crosses. Third is to find y-intercept. Find y-intercept. You basically put x is equal to 0 and find the value of y, which is very easy to do. There is not much problem in that. Fourth step is use symmetry if applicable. Use symmetry if applicable to help draw the graph. What does that mean? It means is A, y-axis symmetry. You have y-axis symmetry when? Wherever is your x, you're going to replace your x with -x. If it comes out to be same as the original function, it is y-axis symmetry. Origin symmetry. Again, you put in your fx, wherever you see x, you're going to replace it with -x. And if sign of each and every term changes, that means it is symmetry with respect to origin. In bracket, you can say whatever on left side, same on right side. That's. And symmetry with respect to origin means whatever you have here, you will have here. Or if you have something like here, you will have the same thing here. That's known as symmetry with respect to origin. Origin becomes a mirror. If you are standing here, your mirror image will come out here. If it is here, it will come out here. With respect to y-axis, whatever is on the left side, on the right side of the graph, you will have exactly the same thing. So fourth step tells me about symmetry. Fifth and the last step is, it says, use the fact that maximum number of turning points of the graph is n-1, where n is degree. You're gonna understand these steps, don't worry, we're gonna do it. Okay, so let's take an example. I'm gonna take example as fx is equal to x to the power of 4. Okay, wait, let me, this is gonna become tougher. Let me take an easier one first. -2x minus 1 square over x plus 2. You have this thing here.
What does step 5 say?
Use the fact that maximum number of turning points of the graph is n minus 1, where n is degree. I want to do this problem with you guys. Okay, I'm going to go step by step. So my step 1 says use a leading coefficient test to determine the n behavior. Can I have Jamila?
Hi.
Hi. Okay, Jamila, can you tell me what's my n and what's my an?
Okay. Hold on. Your n is. Wait, I have a question. Do you have to distribute it or FOIL it first?
No.
Or do you?
You don't have to do that in this case. I told you how to figure out without using the FOIL method.
Oh, okay.
We did this today, how to use it.
Oh, okay. Just give me a second. I'll do it.
Yeah.
2 minus 1 x plus 2.
Okay.
Is n just 2? I mean 4.
So, okay. So here you don't have any x, right? With negative 2. What about here? What do you think will be the highest power of this term? X minus 1 whole square.
The highest part?
If I open it, if I multiply x minus 1 whole square, if I try to open it, what do you think will be the highest power of x?
X squared.
So it will be 2, right?
Yeah.
What about from here? What's the highest power of x here? In x plus 2?
Just 1.
Just 1. So basically you just add them, you got 3. So your n will become 3.
And equals 3.
In here you have an here. So first you have already, from this you're getting a coefficient negative 2. You said x square will be the highest one, right?
Yeah.
What do you think will be the coefficient of x square?
1.
1. What about this one? What's the coefficient of here x?
1.
1. For an you multiply. For degree you add, for an you multiply. Negative 2. Okay. N odd and an negative. What happens when n odd, an negative?
Odd and negative. Up, down.
Yeah, it's going to be up on this side and down on this side. That's what I know. Okay, that's my step 1. Good. Okay, Cameron.
Yeah. Oh my gosh, yeah.
I need to find my x-intercepts now. My next step is to find x-intercepts. For x-intercept, you just put it equal to 0. When I put it equal to 0, I get 0 is equal to negative 2 x minus 1 whole square over x plus 2. Right? How do you find the zeros?
Would you
put each of them, they already in factor form, they already put each of them equal to 0.
0.
Yeah, so you get x minus 1 square equal to 0, x plus 2 equal to 0. This cannot be equal to 0, that's for sure. Here I take square root on both sides, put a plus minus sign, you get x minus 1 is equal to plus minus 0. But there is nothing known as plus minus 0, but since they are coming out twice, I'll write 0 as twice. And here when you solve, you get x is equal to negative 2. So from here I get x is equal to 1, x is equal to 1 and x is equal to negative 2. So let's see what happens. Let's gonna make table. So you had 1 0 and negative 2 0. These are the 2 points you got. What's the multiplicity of 1 0?
2.
And negative 2 0?
2.
Negative 2 0. How many times is negative 2 coming here?
Oh, 1.
So it's 1 only. So 1 0. So let's mark those points. 1 0 you said is gonna, my graph is gonna, it's my x-intercept, and negative 2 0. So these two. These two are my x-intercepts. But since 1 0 has multiplicity 2, 1 0 has multiplicity 2, that means my graph is gonna go here, touch it and turn around. I know, something like this. My graph is gonna look like this. And here, since it's even, it's gonna look like this. Negative 1 has odd multiplicity, that means it's gonna go here, touch and cross. That's what it's gonna do at -1 and negative 2, 0. I know my graph is something, so I'm getting to my graph here. Let's see. Step 3, y-intercept. For y-intercept, you put x is equal to 0. So you get fx is equal to -2, 0 minus 1 square, 0 plus 2. When you got negative square, -1 square, and then 2. And you solve, you get -2 times 1 times 2, which is -4. -4, 0. Let's mark. For here, you don't need multiplicity. Multiplicity you need only for x-intercept. I got this point here. Perfect. Okay. Step 4. Technically, you don't need step 4. You don't need step 4, but it's just for because you're doing your exam on my lab. They may ask you, that's why I have to teach you, but in general, it's not that compulsory. But what you're going to do in step 4 is you're going to replace x with -x in your original problem. You're going to replace your x with -x in the original problem. They're doing step 4 or not. Yeah. And then solve. But let's see. Yeah.
Miss K, is it turning around at 4 or passing through it?
-4?
Yeah.
For -4,
the y-intercept.
For y-intercept, you don't check multiplicity. It is just this point. For x-intercept, you check multiplicity. Yeah. So technically, from here only you will get your graph. By the third step, you will get your graph. How you do it is connect. So it's going up like this. Okay, perfect. It's gonna go touch this point, make a turn here. Perfect. But you are like, how I'm supposed to do this? How I'm supposed to connect this here? It is upward facing. I cannot connect, I cannot cross this line. But note, I said since here it was even multiplicity, it could go like this, or it could go downward also. It's not compulsory, it's gonna go up only. So maybe my graph had like this initially. And then you connect all of them. And then the arrow is downward. Note the degree was what? 3, right? The degree was here, degree of my problem was 3. Step 5 says maximum curves will be 3 minus 1, 2. Note how many curves I have, 1, 2. That means what I drew is correct. Step 5 basically tells you can check. Since my degree was 3, my maximum curves here will be 3 minus 1. Subtract 1 from degree. 2. See, I have 2 curves. That means my answer is correct. One thing I did not teach you is step 4. Try yourself step 4, but I'm going to do this problem, 1 or 2 problems again on Tuesday with you in the next class. So, because I just rushed up with the problem, but I wanted to do it so that you know at least how to do it. But we will do more problems on this on Tuesday, next Tuesday. Yeah.
So is this, like a question like this, going to be on our next homework?
Yes, it will be there. But yeah, but I'm still going to do it with you on Tuesday. It will be there, yes. Okay, so let me take attendance. Okay, XCQ is not here. Wyatt?
Here.
Wyatt is here. Minhan? Here. Jaden?
Here.
Jaden is here? Yeah, he's there. Okay, and do I have Alexander here?
Yeah, I'm here.
Alexander is here?
Yeah, I came a little late, but I'm here.
Okay. What about Jacqueline is not here, I know. Okay, what about Elizabeth? Oh, Kaylee?
Here.
Faith is here. Maximus is here, I know. Carmen?
Here.
Okay, Mason is here, I saw. Andrea?
Here.
Gabriella?
Here.
Leah? Leah was here.
She got kicked off,
Yeah,
but she was here earlier.
Yeah, okay. So the only people I don't have is Evander, I don't have Execuo.
No, wait, I'm here. Sorry. I was having troubles with my internet earlier. I tried typing out the answer, but then Aiden already answered it.
Okay.
Remember, SEQ emailed you about not being here Thursday and Friday.
Yeah, okay. Execuo is not here. Okay, and then what about Jacqueline? She's not here. She informed me too. Okay, I mean, that's it. Okay, guys, I have everyone's else attendance. Okay, thanks, guys. See you on Tuesday. Have a nice weekend, guys. Take care.
Thank you, Ms. K.
Take care, yeah. Thanks. Okay.
Thank you.
You're welcome, guys. Take care. Have a nice weekend.
Miss K, if no one else is going to talk, I have a few questions from chapter 2 homework since we have a test tomorrow.
So the thing is, I can help you, but I know Maximus took an appointment for me, so maybe I'll help you.
How about Jam can go first, and she'll probably answer some of the questions that I have too.
Okay, perfect.
So she can go first. I'm not in any rush.
It's gonna help you guys. So both of you, it will help you guys. What about you, Faith?
I also had some trouble with the homework number 5 because I missed our 5th lecture.
Okay, you have problem with homework number 5. So what you can do? Can you come at around 4, Faith? Okay, so you come around. Actually, come around 3:45. Okay.
Yeah.
I'll see you at 3:45. Perfect. Or if you wanna stay, just stay here. You can listen. I'm doing the problem.
I think listening will be beneficial, so I might just stay.
Okay. What about you, Alexander?
I was wondering if I could review with you guys a couple of questions with what they had.
For today's?
Yeah, for today.
Okay, Alexander. Today I want.
Oh no, not today. What Jamila is doing.
Okay, so I have
just to review 50
so
questions.
I have here these people. You can always stay. You're welcome to stay. Okay, Jamila. Let's see what you have.
Okay, let me pull it up really quick.
So what you're gonna do is, Jamila, share your screen with me.
I don't know how to do that.
Okay, so see on the top here, do you see it says share screen? It will so wherever your Zoom is open, it will say share screen. Share your screen there. See, there will be a share screen button on your Zoom.
Screen share.
It's on the bottom next to like chat and participants. It says share screen.
There's like participants chat. Oh, that's what that means?
Yeah.
Oh, okay. I thought it meant like share the link. Okay. Actually, does someone else want to go first while I log into my account on this computer?
Okay, Maximus, let's go.
I kind of have a lot of questions. So,
it's okay. We are here to practice.
The functions.
I cannot hear you, Maximus. Maximus, you mute yourself.
Oh, sorry.
Yeah.
Here, let me.
You again.
Can you hear me now?
Yeah.
Okay, sorry. So the range and domain of the functions in homework 3, I got it like after the lecture, and then I did some problems the day after, and then I guess I just didn't understand it when I went back to the homework a couple of days later.
Okay.
Right. So it's like you know how in my math lab it gives you certain types of questions for each question, and it changes the numbers every time. So it's like question 7 and on. I like don't really understand. Do you want me to share my screen?
So yeah.
So we can go through one of them.
Yes.
Okay. Let me. I think it's this one. Can you see the my math lab?
Yes. So let's open questions.
Right. Oh, I have to share a different one. Hold on. There you go. Okay. This is homework 4.
Okay. So what I want you to do is, do you know how to find f plus g, f minus g?
These are easy. I meant to do homework 3. I'm sorry. I'm a mess.
It's okay. Take your time. It's okay. Take your time. Relax. It's okay. We are here to solve. It's okay. I have time.
Okay. Let me go back to Zoom and share my screen. There we go. So this is kind of confusing.
Okay, so this is one you picked up, is the most complicated one. Okay, let me help you. So h of x is equal to 15 over 2 over x minus 1. Okay, let's see. So now let me share my screen. So you had this thing here. Okay, we had to find the domain. Okay, I told you domain in generally is negative infinity to infinity. It's always negative infinity to infinity except 3 cases. When there is a square root in the numerator, when there is a denominator and square root in the denominator. Maximus, what do you see here? Do you see square root first of all?
Hold on. There we go. No, I don't see a square root.
Okay. Do you see a denominator?
Yes.
What's a denominator?
2 over x minus 1.
When you have a denominator, what do you do?
Not equal to 0.
Exactly.
Okay.
But do you see in this question specifically, do you see another denominator?
Yes, x.
So you'll put that also not equal to 0.
Okay.
Okay. So let's solve this thing now. 2 over x minus 1. First of all, how do I do it is, it's minus 1. So I can write it as 2 over x minus 1. I can write as minus 1 over 1. I need to make common base. Here it's x, I need here x. So I'm going to multiply here x, multiply here x. If you don't know this method, do the cross multiplication. It is 1 cross multiply. Whichever method you're comfortable. What does it become? 2 minus 1 over x, 2 minus 1x not equal to 0. That's what you get. Make sure when you multiply, if you're multiplying your denominator, you have to multiply your numerator also with x. That's what you get here. Next thing what you have to do is, I want to get rid of this denominator here. How do I get rid of the denominator, Maximus?
By adding times the interval sides.
Yeah, multiplying by x. Since x is dividing, I multiply both sides with x. Here it gets cancelled. I'm left with 2 minus x is equal to 0 times x is 0. Now I just need x. What I do is I add x both sides. You get x not equal to 2. So now you have 2 points, 0 and 2. These are not included. So if I have to write my domain, it will go from negative infinity to 0, open, because 0 is not included. Then 0 to 2 and then 2 to infinity. And note this is union. This union is known as OR. So sometimes I ask you in the question to put this union.
Okay. Infinity. Okay, that makes more sense. Now that's why, because, yeah. Okay, I was confused. Okay, do you want to go to the next one?
Yes. Anyone first? Jamila, Faith, Alexandra, any questions with this problem? Everyone good?
When you're multiplying the fraction, the 2 minus 1x over x, when you multiply the x to get rid of the denominator, it only affects the denominator? Like you're not adding anything to the numerator?
No, because
Okay,
it just cancels, yes.
Okay, it just cancels each other.
That's the purpose of multiplying, to cancel. Yeah, perfect. Okay, Maximus, share your screen. I'm going to stop mine first.
Okay, go to 8. And then here's another one. Is this like the same? Can you see?
No, I cannot see it right now. You have to share.
Where did you go? Hold on, I have to go back. There we go. Share. Do homework. Okay, can you see it now?
Oh yeah. So I want you to do this one yourself. Let me write it first.
Oh no.
You're gonna get. It's the same thing we did right now. Same exact thing we did right now.
Okay, hold on. Let me write it down. Are you gonna share your screen too, or am I just gonna talk to you? Oh, there you go. Okay.
Yeah, I'm gonna share, and you're gonna give me step by step what I'm gonna do.
Since there's no to the power of 2, we equal it to 0, so it would be 14 over x minus 3 minus 2 is equal to 0.
Yes.
It's not equal to 0. Okay. And then since we have the x minus 3, that would also mean x minus 3 is not equal to 0. And that's easy because that means x is not equal to 3. Let me go to the other side, right? And 14 over x minus 3 minus 2 over x.
2 over what? What is 2?
X.
What is right
or
now?
1. I mean 1.
Yes.
There we go. Okay. What is that noise? Sorry.
It's okay. It's okay.
2 over 1, and then we multiply both sides by x.
X what?
Right.
Why x? Here it is x minus 3, right?
Mm-hmm.
So I need x minus 3 here also. So I'm gonna multiply by x minus 3.
Oh, okay.
In the top problem, I had x. That's why I was multiplying with x. But in this case, I have x minus 3. So I'm going to multiply by x minus 3 to make the same base. So what does it become? 14 minus 2 x minus 3 over x minus 3. I take only one x minus 3 since I make it common.
Okay.
And when you try to solve a numerator, it becomes 14 minus 2x plus 6 over x minus 3 not equal to 0.
Oh, I see. You foiled it. Okay.
Yes, I opened it, distributed. Okay. What's the next step?
Multiply both sides by x minus 3.
Perfect. You multiply both sides with x minus 3. Here they get cancelled and 0 times that is 0. I'm going to combine the constants. 14 plus 6 is 20. You get 0. If you
so, wait.
You get x not equal to...
Wait, 2x. Oh, I see. Okay.
So what's my domain, Maximus?
What did you say?
Domain.
Okay, it's negative infinity, comma 3.
Mm-hmm.
Hi. I'm on a college class, Bev. Thank you. Yeah, I will be, but I'll talk to you later. Bye. Sorry.
It's okay.
It's negative infinity, comma 3. Those are both open parentheses. Union 3, comma 10.
Yeah.
Open parentheses.
Then union 10, comma infinity.
Union and then 10, comma infinity. Yes. Open.
Was that your girlfriend? Girlfriends are important, trust me. Was that your girlfriend?
What?
Was that your girlfriend there?
No.
Oh.
No, that I'm at my mom's work right now. Yeah, so she works at a retirement community, and that was one of the residents named Bev Dexter. She's